Welcome back to Dave Does Math from Home. This is part two. There it is. Part two of our video series on polynomials. In this one, we're talking about multiplication. If you are familiar with FOIL, if you are comfortable with FOIL, you can probably skip a couple minutes ahead. If you are not familiar with FOIL or you think you could use a little refresher on FOIL, then stay tuned. We're gonna explain what FOIL is and how it works, but first we're gonna explain why it works and where it comes from, so that we're nice and grounded. Multiplying polynomials is a little bit more complex than you might expect. If you have something like 3x minus 4 times 2x plus 5. These are the two polynomials that we want to multiply together. We can't just multiply these pieces and multiply these pieces. This does not work in the same way that combining like terms works, where you can just combine these guys and then combine these guys and then you're done. You have to combine each piece of this with each piece of this because that's how the distributive property works. So if we pause this for just a moment and we come over here and we look at something like 4, or not 4, let me do something else. Let me do 7. We'll do 7 times 2x plus 5. If we were doing this problem, and the thing in front wasn't a polynomial, it was just a number, we would be pretty comfortable distributing this 7 to these two things, and we would get 14x plus 35. No problems there, right? It's pretty straightforward. It's what you'd expect to happen. This thing here, I want to treat it the same way. This whole piece, that's like the blob. That is one blob unit. If I multiply this blob in here, I'm going to get 2x times the blob plus 5 times the blob. That's what happens if I pretend that this 3x minus 4 is just one thing and multiply it by both of these guys. But this one thing is actually 3x minus 4 plus 5 times 3x minus 4. So now I need to distribute these two pieces as well. And you end up with 6x squared here. There's a negative 8x. Here we get a 15x and a negative 20. So when you have, this is called a binomial, because it's a polynomial with two pieces. Bi means two, like bicycle. This is a binomial, this is a binomial. When you multiply two binomials together, you should end up with 4 pieces. 1, 2, 3, 4. If you want to skip these two intermediate steps where you basically just distribute things twice, because that's all we're doing. We're distributing the blob into these two pieces, and then we're distributing each of those two pieces into the pieces of the blob. It's a double distribution step. If you want to skip the double distribution step, there's a sort of a heuristic. What's it called? It's not an aneurysm. Mnemonic. Why was I thinking of aneurysms? Ana something? I don't know. I have no idea what I was thinking. There's a mnemonic device that can help you remember what the 4 pieces you should get are. And the mnemonic device is FOIL, which stands for first, because this is the product of the first two, 2x times the 3x. This is the inside, I guess, oh, I misspelled FOIL. This is the inside, and it's negative 4 times 2x. This is the outside. So the inside means these two pieces, outside means these two pieces. The pieces that are closest together are the inside, the pieces that are furthest apart is the outside. So this is your 3x times your 5. And then this is your last, which is your negative 4 times your 5. And so I have apparently spelled feel because I love to do things out of order. But the good news is the order doesn't matter. Most people are going to switch these two, and then they can call it FOIL. So the first, the outside, the inside, and the last. So the order of these pieces doesn't matter at all. It's all addition. If you pretend that this isn't actually subtracting 8, if this is like adding -8 and this is adding -20, then it's all addition and the order doesn't matter at all. So you can do FEAL or FOIL or whatever other combination you want. This is just a quick heuristic to get you to remember that there should be 4 distinct pieces. So that's FOIL, and that's where FOIL comes from. We're going to do just a couple more examples of foiling things real quick, and then we're going to make things a little bit more exciting. Let's talk about, let's do big numbers now. Let's do 7x squared plus 3 times 8x minus 9. Okay, we can FOIL this. Should make things pretty simple. We'll start with the first. The first should be 7 times 8, I guess, is 56x cubed. The x and the x squared gives me the x cubed. I'm going to stick with, I don't know why this. No, we'll do FOIL. We'll do the outside should be -63 x squared. The inside should be +24x, and the last piece should be -27. I only just now realized that in the last example that I already erased, I forgot the step at the end where I combine the like terms. You should not forget that step. In this problem, we have no like terms to combine. We have a cubic, a squared, a linear, and a constant term. So none of these are like terms. There's nothing to combine. We can just put a box on it and be done. But I should do another example of foiling things where there's like terms to combine. Let's just do x minus 4 times 2x plus 3. First should give me 2x squared. Outside will give me 3x. Inside will give me -8x. And the last will give me -12. And then these two pieces are like terms, which means I can combine them. 2x squared minus 5x minus 12. And we're all set on that one. So we can FOIL things, we can combine the like terms we get from foiling things. Works out pretty well. All is well. But I promised more exciting things. So it's time for some more exciting things. In the last couple videos, I talked about what happens when you square something. We talked a lot about how if you have something like 5x squared, you can distribute the exponent into these pieces and you get 25x squared. And that if you have x plus 5 squared, that doesn't work and the exponents do not distribute and you have to do something else. That something else is FOIL. X plus 5 squared means x plus 5 times x plus 5. And we can just multiply these things normally. We get an x squared. The inside is 5x. The outside is 5x. The last is 25. and we can combine the two 5x's into a 10x. This is what you get when you square x plus 5. If you try to square each piece, you'll get the x squared, you'll get the 25, you will be missing the 10x. The 10x is very important. So don't skip this step. Don't try to skip steps and not FOIL this. Just FOIL it. That's how you make it work. The other more interesting thing we're going to do in this video is, I guess I don't need that multiplication thing anymore. I want to talk about what happens if we do something like 2x minus 3 times x squared plus 5x minus 8. With this example, we have left the realm of FOIL. FOIL works when you have a binomial times a binomial, 2 times 2. Here we have a binomial times a trinomial. FOIL is an acronym for the 4 pieces you get when you multiply 2 binomials. First, inside, outside, last, because there's just 4 pieces. When you multiply a binomial times a trinomial, you should get 6 pieces. It becomes a little more difficult to organize these 6 pieces. There's no good heuristic for that or mnemonic. Here's how I do this. I do it in rows. So I will take the 2x times this whole thing, and I will make that into a row. 2x times this piece will give me 2x cubed. 2x times this will give me 10x squared. And 2x times negative 8 will give me negative 16x. So this is my first row. This is the 2x times the whole piece row. And then I'll take the negative 3 and I'll multiply the negative 3 by each of these, and I'll make that a new row. And I'm going to try to line them up by like terms. So what does that mean? Negative 3 times x squared is negative 3x squared. And I'm going to put it right here because I want to line up all my like terms. Negative 3 times 5x will be negative 15x, and I'll put that here because I'm still trying to line up like terms. Negative 3 times negative 8 will be positive 24, and that can have its own column because there's no like terms up here. So this is the 3 pieces from the 2x. This is the 3 pieces from the negative 3. These are all 6 of my pieces, and now I can just add them together straight down. 2x cubed plus 7x squared minus 31x plus 24. This is how I do this. If you know a different way, if you prefer a different way, if you like to organize this thing differently, do whatever makes the most sense to you. Do what makes you happy and will produce correct answers very consistently. I'm not going to enforce or mandate that you use a specific technique because I don't think one technique is inherently better than the other. The correct technique to use is the one that makes the most sense to you. So with that in mind, there is another technique that I have seen for doing problems like this, for things that are bigger than FOIL. I think most people call it the box technique. And it's not something that I use often, so I'm not very familiar with it, but I will try to recreate it here. Usually, when we have in-person classes where people are actually in a classroom with me, and we get to this part of the lesson, I'll ask who in the class is familiar with the box method, and then I'll make them come up to the chalkboard and do it, because I honestly don't know it very well. But I'm going to see if I can stumble through it. We'll do our best. I think with the box method, you want to put the pieces of this down the side, and you want to put the pieces of this like across the top, and then make little boxes for like the 6 things you're going to get. So like this product will give you 2x cubed, and this product will give you negative 3x squared, and then this product will give you Or maybe I'm supposed to have this over here, 2x and then negative 3 on this side. Right? Yeah, I think they're supposed to be over here. This product will give you 10x squared, and this product will give you negative 15x, and this product will give us negative 16x, and this will give us positive 24. And these 6 pieces are the same 6 pieces we got up here. There's just sort of putting them in a grid like this sort of helps organize. So you know you've gotten all 6. And like you can tell where each piece came from. Like this piece came from these 2 being multiplied together. And then you can combine like terms. I think you combine like terms sort of down the diagonal. So this is your only cubic term, and it's 2x cubed. And these are your 2 squared terms, and that's positive 10 and negative 3 is 7. So now we're adding them. We've already done all our multiplications. We're just combining like terms with these arrows to add them together. Negative 15 and negative 16 will give you your negative 31, and then you have your 24 on the back end. So we get the same thing. 2x cubed, 7x squared, negative, that doesn't look like a 31 at all. Negative 31x, positive 24. You get the same result. It just imposes some organization on it. If you like the way this looks, if you want to use this method, great, go for it, do this method. If you don't like the way it looks, you want to use this method, okay, use it this way. This is my favorite. Honestly, it kind of doesn't matter. You can do whatever you like with these problems. As long as it's making sense and it's getting you some correct answers, then go for it. There's one last thing I want to talk about. Now that we know about this, that last thing I want to talk about is what do you do with 2x plus 3 cubed? We know, because we've been watching these videos very carefully and paying close attention, we know that we can't just cube these pieces. If you try to tell me that this is 8x cubed plus 27, I will be upset, because it's not that. We know that if we square this thing, we'll just have 2 pieces. We can FOIL them. If we're cubing it, we have 3 pieces. I said the word 3 while trying to write the number 2, and it didn't work. 2x plus 3 times 2x plus 3 times 2x plus 3. These are the 3 pieces we have. What we have to do for this is we have to do it in pieces. If we consider just these first 2 pieces, this one can stay on its own for now. We'll deal with this one later. If we just worry about these first 2 first, then this becomes a FOIL issue. First will be 4x squared. Inside is 6x, outside is 6x, last is 9. This piece, 2x plus 3, is still just hanging out. Nothing has changed with that yet. I can combine these like terms, so I get 4x squared plus 12x plus 9. Sorry, I want to use big heavy square brackets for this one. Times 2x plus 3. Now we're in the box situation, or the 2 rows situation, however you wanted to think about this one. We're in this situation where we have a trinomial times a binomial. So we can handle this. I'm going to do this 2x times everything, and that'll give me an 8x cubed plus 24x squared plus 18x. This is the 2x row. The 3 row is going to give me 12x squared, 36x, and 27. And then I can just add these 2 rows together to get my 8x cubed plus 36x squared plus 54x plus 27. That's how you cube something. And that's the end of our video.